In this video, I'll talk about the location of the Andromeda Galaxy in the sky and discuss some images of the galaxy. I'd like first to show this page from heavens-above.com. Heavens-above.com. I have no affiliation with it. It's just a useful site for plotting the sky for your location. You will have to set your location when you first reach the website. And here we are, February 7th, 2018. I set it for about 8:30 p.m. and we have the Great Square of Pegasus over here towards the west horizon, a little bit northwest, and Andromeda, the Andromeda constellation, seen off to the left of the Great Square of Pegasus. If I can get rid of some other things here. But Big Dipper, North Star, south is right down here. We could scroll a little bit. So Orion in the southern sky, and give you a little clue as to where you would look for Andromeda. Orion, Taurus the Bull. We have Perseus, Cassiopeia, the W in the sky, and Andromeda here. You'll see it as a V-shape group of stars going off one corner of the Great Square of Pegasus. This corner star is in Andromeda constellation. These three stars are in the constellation of Pegasus. Let's go to my PowerPoint here. So we're going to see a visible light photograph of the sky. Here's the Great Square of Pegasus, and we have this V-shaped pattern of stars. And at this bright star in the middle of the V, a little dimmer star, and then this fuzzy patch is the constellation, the Andromeda constellation. You'll need to be in a dark sky location, that means outside of a city, in order to see the Andromeda constellation with your eye, but it is visible to your eye. So the Andromeda constellation in February, we're getting a little bit close to the west horizon in the evening, but back in October it would be over in the east horizon. So use heavens-above.com to locate it. And then if we go to visible light, we have here the Andromeda Galaxy, a portion of it anyway. It is a spiral type galaxy, as the Milky Way is, has a disk where new stars are being born, and we have dust lanes and so forth. It's a spiral galaxy. It's not identical in shape to the Milky Way, but it is a spiral type galaxy. It has a disk. Around 1925, the astronomer Edwin Hubble was able to determine the distance to the Andromeda Galaxy. Won't go into those details here, but currently the distance calculation, 2.5 million light years from the Milky Way galaxy. The meaning of that is that it takes light 2.5 million years to go from one galaxy to the other. And the Milky Way galaxy is about 100,000 light years across. The Andromeda Galaxy is about 260,000 light years across, about 2 times the size of our galaxy. The photograph brings out the dimmer parts of the galaxy you will not see with your eye. You'll mainly see right in here with your eye. But from edge to edge, roughly for the Andromeda Galaxy, 4 full moons would be the size across the sky. So 4 full moons, and you have to imagine I'm drawing a moon there. 4 full moons across the disk that we're seeing here, and there's some more faint material, so 6 full moons from what you might call an edge to edge, but 4 full moons where it's bright in the disk. And that's from Peter Kennett, 2005, Wikipedia Commons websites where I found that photo. With some satellites, we can observe astronomy objects in other wavelengths than just visible light. So we have the information here. It's a composite photograph with 3 wavelengths of light being used. The Galaxy ultraviolet telescope for 2 of these. The blue coloring are the hottest regions. Ultraviolet light being recorded. And this is where we have new stars being born, hot, massive stars, star clusters in the blue light. The green are a little bit older stars. They're cooler, and won't go into the ages of stars, but just using temperature, we can estimate the age just a little bit. There's more to it than that, but little older stars. And then the red is interesting. Now using infrared light, the Spitzer telescope has recorded this image in infrared light, and we see where there's dust giving off light, but much cooler than the stars, and light out in the infrared part of the spectrum. So center, we have here a lot more density of stars, more stars per unit space than towards the outer edge, but you can see these rings of gas and dust and stars around the center of the Andromeda Galaxy. Then just the more pure ultraviolet light from this same satellite, the Galaxy Explorer satellite, and this is pasted together with 11 images from the satellite laid next to each other to span the whole galaxy. But again, we see these blue areas where we have hotter material, younger, more massive stars giving off the ultraviolet light, and then these orangish yellow regions where the object is cooler, not giving off as much ultraviolet light. But interesting shapes and lanes in the galaxy. Now back to more of a visible light with the Hubble telescope, just showing a portion of the Andromeda Galaxy, 48,000 light years wide across here. And if you remember, about 260,000 light years wide is the whole galaxy. So we're just seeing a portion. The darker areas, that's where dust is blocking the light from more distant stars. You can see individual stars with the Hubble telescope's resolution, and we had clusters of stars in these more highly blue areas. There are many, many, many stars, thousands of stars in each of these clusters. But the Hubble telescope can resolve individual stars in the Andromeda Galaxy and make us more detailed studies. Again, with the Hubble telescope, this inset looking towards the center of the Milky Way galaxy, there are two concentrations of light. One is bluish. This group of stars, again, are young stars, hot stars, more recently formed. And it's interesting, in the center of the galaxy. Inside the cluster of blue stars, there's a supermassive black hole. The light coming from the stars and the dust, the gas around here, that light is Doppler shifted. Because of motion, the wavelength of the light coming to us changes. We get a blue shift when the light is coming towards us, red shift when it's moving away. That does not make the color of the stars. It's a small effect, but with our instruments on telescopes, astronomers can detect the shift of the wavelength of light, and that indicates that there's a supermassive black hole in the middle of this blue cluster of stars that is possibly up to 200 million times the mass of the sun. 200 million times the mass of the sun. And then the orange light here, older stars, they're still orbiting the supermassive black hole, but some people call this a sort of a double nucleus. There are two kind of clusters of stars, and they have their own properties, younger and older. But there is a supermassive black hole in the center of most galaxies. By studying the motions of stars and gas using the Doppler effect, astronomers have confirmed that most galaxies have supermassive black holes in them. And there's some other evidence as well that we won't go into. And back now to the visible light photograph. Again, I hope you'll go out to the sky and look for the Great Square of Pegasus in February, more towards the western horizon at after sunset. Then this V-shape pattern of stars. And then we have the Andromeda Galaxy, this blur that you'll need to be in a dark location to observe it. Then if you would like to look at some other physics and astronomy videos, physics.gpclements.com, astronomy.gpclements.com. These two websites are totally free. There's nothing for sale at these websites. You do not give your email address to me. You just use them as you see fit, and hopefully you'll find some useful information there. A full introductory physics course, a full introductory astronomy course, lots of sample problems for the physics course, a few problems for the astronomy course, and you can look them up by name, and you'll be able to read how many minutes the videos are, typically 10 minutes, and description of the content for each video. If you'd look on that on my YouTube channel and watch one of the videos, I'd appreciate it if you would subscribe. Click the subscribe button and you'll get a notification when a new video is posted. So happy viewing. Hope you're able to see the Andromeda Galaxy in a dark location with your eye.